Welcome back to TrainSignal's VMware vSphere 5 training. You're watching Virtual Storage 101 and Storage Terminology lesson. Alright, so it's no secret that storage is currently my favorite topic. It just makes everything around virtualization. Virtualization in general revolves around storage these days. So this lesson is really dear to my heart, so you're going to have to bear with me. I've packed it with enough information to take you from, yeah, I know a little bit about storage, to I know storage kind of thing, you know, on that kind of Matrix Neo thing. Alright, so what are we going to cover? We're going to start off by Storage 101. What are virtual disks? What's VMFS, etc. We're going to talk about the different types of data transfers that are available for storage and IP storage and SCSI and Fiber Channel and all that good stuff. We're going to compare storage technologies. We're going to see the difference between NFS and iSCSI and Fiber Channel. We're going to talk about storage area network. What makes up a SAN? What is a SAN? SAN 101. We're going to talk about Fiber Channel SAN components. What are the different components in a SAN? You have to understand the different components. You have to understand that a Fiber Channel switch is also known as the fabric, the HBA cards, how everything ties together, the service processor or storage processor. You need to understand all these components. We're going to talk about how to address Fiber Channel. How does it work in a Fiber Channel SAN from a LUN's perspective? We want to understand iSCSI storage a little more. We want to understand why we need a SAN. What are the benefits of a SAN? Storage terms you must know. We're going to talk about, well, what do you need to know? For example, again, you need to know that the fabric means a Fiber Channel switch and so on and so forth. I'm going to list the different terminology here that you must know when you're discussing storage. We're going to talk about what is a data store? What constitutes a data store? What kind of files, what kind of folders can you put on a data store? We're going to talk about the different storage options that ESXi has at its disposal. We also want to talk about some of the VMFS, the virtual machine file system, specifications and maximums. This is going to be a loaded lesson, so let's go ahead and get started. So Storage 101, virtual disks and the VMFS. So I've put here kind of like, you know, a quick definition, a VMware definition of, you know, what a SAN stands for. So I'm going to let you guys read it. I'm not going to go over that. But the important thing, the takeaway here to understand is that there's an abstraction between the actual storage and the VMs. The VMs don't know that they're running on a SAN or a Fiber Channel or iSCSI, or they don't care, they don't know. All they care about is they care about virtual disks. So the VMs, as far as they're concerned, virtual disks are at the end of the road from a storage perspective. What you're doing after that, that's your problem. They don't care about it. Virtual disks can be managed easier. You know, it's very simple, right? You have two virtual disks. One constitutes the C drive and the other one constitutes the D drive. Copy them, move them, delete them, whatever you want. It's very easy to add, create, remove. Now, the virtual hardware that constitutes the virtual machine, it has a virtual SCSI controller. That virtual SCSI controller is what gives the virtual machine access to these virtual disks. And that's important to understand because with the virtual hardware, you can select different types of virtual SCSI controllers. And those different types of virtual SCSI controllers will give you different performance access to these virtual disks. So for example, you have bus logic, you have LSI logic parallel, you have LSI logic SAS, you have a VMware para virtualization. These different virtual SCSI controllers were created for different workloads. They were created to handle different types or IOPS profiles. So again, depending on the type of application that you're trying to deploy, if you're deploying a Microsoft SQL Server or a Microsoft Exchange, you probably want to use the VMware para virtual SCSI controller because that will handle 2000 IOPS or more. So it's configured to handle heavy load, etc., etc. Now the virtual SCSI controller within a VM also gives it access, so it can, you know, read or access, read VMFS data stores, NFS data stores. NFS stands for Network File System. That allows you to also access these data stores. It can also access raw disk mappings. Raw disk mappings, otherwise known as RDM, is when you're taking a LUN and serving it up directly into the VM. So you're bypassing VMFS, you're bypassing any type of VMDKs, and you're just presenting a raw LUN to, for example, a Windows machine. That Windows machine is then going to format this raw LUN as NTFS. Think of it as the same way when you used to present a LUN to a Windows machine, and it becomes local to that machine. You're doing the same thing here with the virtual machine. You're passing it through the hypervisor and directly connecting it into the virtual machine. So that's, you know, that's the rawest form of giving the VM access to the disk. So if you need some application that requires extreme performance, this is one of the things that you can do. Or if you have a virtual machine, maybe a file server that requires a large LUN, you don't want to create a virtual disk that's a terabyte in size, right? So you can create that LUN as a terabyte and serve it up directly into the operating system, let the operating system handle that. So again, depending on the management style, that might change. VMFS will stand for VMware File System. It's specialized, it's custom or purpose-built for virtualization. It was made to handle virtual machines. It's VMware's clustered file system, which provides distributed locking on the different VMs at the file level. Now, obviously, the virtual machines' virtual disks are also stored on VMFS data stores, or they could be stored on NFS data stores for that matter. VMFS could be local, iSCSI, or Fibre Channel. So keep in mind, there is no VMFS for NFS data stores. That's very important to note. For those of you that are going to sit the VCP5 exam, that might be one of the questions you get asked. So VMFS only supported on local, iSCSI, or Fibre Channel. Now, centralized storage is important and is required for advanced and enterprise class features like vMotion, storage vMotion in some instances if you're trying to move it. But for the most part, vMotion, VMware High Availability, Fault Tolerance, Distributed Resource Scheduler, all of these components have a need for shared storage in order for them to function, in order for them to exist. Most of the time, in most cases, the centralized storage is a SAN. Now keep in mind, and we'll go through this in a little bit, a SAN only means iSCSI or Fibre Channel. If you're talking about NFS, then that's considered maybe like an IP storage. It doesn't really fall under the realm of a SAN. So when you hear the term SAN or Storage Area Network, that's always referring to either iSCSI or Fibre Channel, typically known as block level storage, and we're going to discuss that in a minute as well. So this diagram here, again, this was borrowed from the VMware documentation, illustrates for you what a typical SAN is. So, in lame terms, you got your ESX host, you got your virtual machines that live on it, you have your virtual SCSI controllers, and those virtual SCSI controllers are then going to connect through HBAs to the different storage and VMFS. Underneath it, you have the LUNs and your raw disk, your raw disks or your actual physical disk. I'm going to break it down even further in other slides so that we can talk about the different components in greater detail. But I just wanted to give you a quick snapshot of what it looks like from a connectivity perspective. Alright, so data transfer. This is important for you to know for the exam, but also for your own knowledge. There's two types of data transfer that exist for storage. You have your traditional block level transfer. Block level transfer is anytime you're dealing with iSCSI, Fibre Channel, or local disk for that matter. It's directly attached to the machine, right? So it's all I/O. It's not going over any kind of IP. It's very dedicated pipe, but just for storage. When you're presenting a block level storage to ESX or Windows or anything, you would see that storage as local storage. You wouldn't be able to tell the difference between local and block level. So for that matter, block level in essence is treated the same way as local storage. So it's important to understand here the difference. Whereas file level storage, anytime you're dealing with IP storage, if it's NFS or if it's CIFS and SMB, all of those are considered file level storage or file level transfer. And to illustrate this better, when you map a drive from a remote location in a Windows server, that's considered a file level transfer, except in Windows you're using it over CIFS and SMB. In ESX we're going to be using it over NFS. So NFS is a Linux/Unix-based network or file level transfer protocol, whereas CIFS SMB is a Windows file level transfer protocol. But I'm trying to illustrate here just so you get the general idea. So from a block level transfer, it's strictly via I/O, via the SCSI going over a dedicated I/O. It's almost treated as local, whereas file level, it's almost always going over some kind of an IP network. So it's important here to understand the difference. All right, so let's talk about the different methods by which you're transferring data. So Fibre Channel here on the left, again, you're going from your ESXi host here, you're going through an HBA, and this HBA is different than the Ethernet, the traditional Ethernet cards that you might have today. So HBA is different, but it serves the same function, right? So it's the device that goes into the ESXi host that allows the connectivity The cabling is also different. You have fiber cable here as opposed to just the traditional Ethernet cable. So fiber is different than iSCSI and NFS. iSCSI, while is considered block level, as we saw in the earlier slide, it's still using the traditional components of your network. So you're still using a traditional network interface card. You're using, the Cat5 or Cat6 cables to transfer it to remote storage. So it's also considered IP storage, except the transfer method is different, and same case for NFS or network file storage. With Fiber Channel, it's a little different because your HBA is different. You need a Fiber Channel switch, as we're going to see in a second. The cables are different. So from a Fiber Channel perspective, it's a completely different architecture and an infrastructure that you have to deploy to support it, whereas with iSCSI and NFS, it's standard Ethernet infrastructure that you currently have in place. However, deploying Fiber Channel obviously has its pros, so we'll talk about those in a minute as well. So let's go ahead and compare these different technologies, right? So now I've tried to illustrate this not to knock down any of the technology. So for example, if you see a single dollar digit here, that doesn't mean that NAS or NFS comes cheap. Trust me, there are some NAS/NFS storage arrays or systems that are very expensive, like NetApps, like the Isilons, like the BlueArcs of the world. Those will, the higher end ones will cost you, a fortune. But for the most part, just so you have a general idea, Fiber Channel is considered the most expensive, the most reliable method and form of SAN, or storage for that matter. Fiber Channel SAN and storage, if architected properly, should never go down. It is built to withstand anything. Unless you're yanking the power out of the wall, that thing should never go down. You should not lose data. It is built to sustain and have high availability. So Fiber Channel will typically cost the most, even though in recent years Fiber Channel based SAN has come down significantly in price, where it's affordable even for SMB. Before, it used to be only in enterprise level organizations that are privileged to having Fiber Channel SAN. Today you can get Fiber Channel SAN for very, very competitive pricing when compared to iSCSI and NAS. NAS, again, it's block level, so I'm illustrating here. Both of them can be cheap, expensive, so it depends on how you're configuring it. The advantage of NAS and iSCSI is that you're going over traditional Ethernet, but the disadvantage of NAS and iSCSI is also that you're going over traditional Ethernet, because typically the network, it's resilient when it comes to transferring packets, right? It's not very resilient when you're transferring this data storage. I'll give you an example. If you have an iSCSI or NFS/NAS for that matter connected to ESX, and you have virtual machines that are living on these NAS or iSCSI LUNs, and for whatever reason there's a hiccup on the network, well, typically if you're using just Windows or you're transferring files, that packet gets retransmitted. Where with ESX, if it detects that drop, it's going to drop. And if it drops, then your virtual machines are immediately going to crash. You don't have that with Fiber Channel. Fiber Channel is strictly I/O. So there are pros and cons to each. If you're asking me my preference, I'm still a Fiber Channel guy. I just kind of like it. I like the stability. I like the performance. And Fiber Channel comes in 2 gig, 4 gig, or 8 gig HBAs for that matter. Obviously, you have 1 gig, 100 meg, 10, whatever, but you also have 10 gig Ethernet, soon to be 40, soon to be 100. So Ethernet will always be leaps and bounds ahead of the game when it comes to bandwidth, rather than Fiber Channel is always trying to play catch up for that matter. Storage area network, SAN 101. Again, we covered the fact that SAN could be iSCSI or Fiber Channel. It can't be NFS, so that's important to understand. Fiber Channel SAN packages SCSI commands into Fiber Channel frames, so that's also important to understand how Fiber Channel is transporting the SCSI commands. So it encapsulates them into these Fiber Channel frames, so that's important to understand. Services connect to the SAN using an HBA. Think of HBA as the equivalent of your NIC card, except it can accept a fiber cable, whereas the NIC card will only accept an Ethernet type cable. So just again, to give you some sense of relation here. HBA connects to a Fiber Channel switch. The Fiber Channel switch is typically known as the fabric. Fiber Channel switch connects to a storage processor. I'm going to have a graph here that shows you how each of those different components connect together. But I just want to give you a quick one-liners here. Zones are configured in the Fiber Channel switch, define which HBA can connect to what service processor or storage processor and to which LUN. and then you have ESXi, which fully supports SAN multipathing, which means you can have more than one path to the storage, and that's another advantage of Fiber Channel SAN. Even though you can do it with iSCSI and NFS, it's not as resilient as it is with the Fiber Channel, where you have more than one path to your storage. Alright, so let's break down the components of a Fiber Channel SAN. So at the very top here, you have your ESXi host, and then you have your Fiber Channel Host Bus Adapter, or HBA, otherwise known as the HBA. The HBA will connect the ESXi host to the Fiber Channel switch, otherwise known as the fabric, using Fiber Channel cables. So that's important here to note as well. Then from the switch, you again have Fiber Channel cables that connect you to your storage area network. Now the storage area network consists of a storage processor. The storage processor is going to receive the commands that are sent from the ESXi host through the HBA, through the switch. This is what it's going to receive them here, and then it's going to give access to the LUN. Now the LUN stands for Logical Unit Numbers, and think of a LUN as an aggregate of physical disks. So you come into your storage devices here, and by the way, these are your hard disks, your spindles, whatever you want to call them. This is the storage, what you buy. LUNs are logical groupings, so you carve out 1, 2, 3, 10 of these spindles into a LUN, and then you can add your RAID groups to it. So you can have a LUN that's RAID group 5, you can have a LUN that's RAID group 10 maybe, etc., etc., and then you can format it with whatever you want. Typically, if it's presented to ESX, it's going to be formatted as VMFS. If it's presented to Windows, for example, you'd format it as NTFS. But what you do is you grab the raw devices, the storage devices, you grab as many of them as you want, and the more spindles that you grab, the better the performance, right? You have more horsepower behind that LUN, and then you carve a LUN out of it, and it is that LUN which is then presented to ESXi, and VMFS sits on it as its VMware file system. So again, the connectivity goes from ESXi host through the HBA, through the fabric, to the storage processor, and then to the LUN, and the LUN has access to these carved out storage devices. Very simple. It's very simple, similar to an Ethernet infrastructure, except the components are a little bit different. So Fiber Channel HBAs. So ESX natively supports Fiber Channel HBAs made by QLogic, Emulex, Brocade, Intel. So there's a bunch of them where you have drivers for them. However, now that we've moved on from ESX to ESXi, the number of drivers within ESXi is very limited, and that's why we're using Auto Deploy and Image Builder and all these new features in vSphere 5, because not a lot of drivers are going to come packaged in ESXi. So before you purchase your HBAs, and even though most of your server vendors will tell you if the HBAs that are in their servers are on the hardware compatibility list, in the instance or in the case where you want to actually buy HBAs outside of the storage or server manufacturer, or even if you're buying it through the server manufacturer but you just want to double check that it's compatible, I've given you the address here where you can go on the VMware website and check to see if your HBAs are compatible. Alright, Fiber Channel connectivity once more. So I talked about multipathing a little bit, but I wanted to illustrate it here so that you have a sense of what's going on. So on the right, what we have is a server that typically has maybe one HBA or two HBAs, or maybe one HBA that has dual ports, right? Now, this particular server has one port of the HBA going to the disk, so it's a single path. This is considered a single path since the server is going through the HBA card, through the fiber channel or the fabric, and to the storage device. It has one path. If this path fails, then you've lost access to the storage. In this case, you have a second path here, right? So this second path provides some kind of redundancy if it's configured appropriately so that you have access to the devices using a secondary path. However, if these were going to different LUNs on the storage here, that would mean that you only have a single path to every LUN, which means if this path should fail, you've lost access to your storage, which is unacceptable, right? Especially if you're in an enterprise. So if we move over to the left, you'll notice that here we have an ESXi with dual port HBAs, which means the server has two paths to the storage. So if one of the paths fails, one of the fabric should fail here, it can go through the other way and still get access to the storage. Typically, in enterprises, you'll get ESXi hosts that have 4 paths to the storage, making it literally impossible for that thing to fail. Now, don't hold it against me. I've seen it fail, but what I'm saying is they make it extremely difficult, maybe that's a better term, extremely difficult for you to fail. So it's very, very resilient, and it's built to be very, very resilient with more than one path to that storage. So I wanted to illustrate that again to show you the value behind Fibre Channel, because when you're evaluating these SANs, when you have all these vendors sit in front of you here, and they're talking the value and discussing price, and this is expensive and this is cheap. Well, you have to understand why certain things are a little more expensive than others, right? There's always a cost that comes with everything. Fibre Channel isn't expensive just because it's expensive. It comes with peace of mind, it comes with stability, it comes with performance, it comes with redundancy. So there's a lot of advantages to Fibre Channel SAN. So moving on here, we're going to talk about zoning. So what is zoning? In very brief, zoning is the grouping of multiple HBAs and then giving these HBAs access to certain LUNs. So you'll take HBAs from ESX A, B, C, and D, you'll group them in a group, and then you'll say, okay, group A has access to the following LUNs. Now obviously it's a little more complicated than this. I'm just trying to make it as simple as possible, and we're going to get into this a little later on. But there's multiple types of zoning. There's soft zoning, there's hard zoning, and there's also something known as LUN masking. And a few slides down we're going to get into this. But again, zoning is performed most of the time at the fiber switch or the fabric level. It can also be performed at the storage processor level, as we're going to see later on. Now to give you an example of how zoning might work, since not a lot of you are going to have the ability to have access to storage, or most of the time in the enterprise the SAN administrators won't even let you near a SAN. But just so you have an idea about how this works. So the same way as, for example, if you're imaging servers and you're trying to PXE boot, a lot of times if you're using software, it's going to detect all the Ethernet cards that it sees. Now with zoning and with SANs, it's kind of the same thing. It's going to detect all of the worldwide names that it can see. Worldwide names pertain to HBAs, as we talked about. So as you can see here on the left, it's discovered some worldwide names. Now the process of zoning is you create a zone, and then you add these worldwide names to it, and then you tell this zone which LUNs it has access to. So in the middle, you'll notice that we've included different worldwide names from different hosts in a zone. And then we give this zone access to these LUNs. Now all the way to the right, we've shown you the zones that are existing on the Fibre Channel fabric. So how are LUNs created, or what are LUNs to start with? A LUN is a logical allocation of storage space carved from a set of underlying physical disks. So what this means in essence is you have 10, 20, 30 independent disks, and what we do is we group them together in a logical manner and present them to a host as single storage. So you might have 10, 20, 30 disks that are each independent of different capacities, and then you group them together, you carve up a LUN of a specific size, and then you present this LUN as local storage to a host. Now you can do RAID 5, you can do RAID 0, you can do RAID 1+0, you can do all types of RAID that are supported on a SAN. So this next slide is actually really cool to show you how things are done. So as you can see towards the middle here, we have disks. Those are the disks that are available, and you're going to notice that the type or the size of the disks that we have are 4 gig disks. So then immediately under that, you'll notice that we've created LUN 1. Now LUN 1 is RAID 5. So we've added these disks into LUN 1, and then we've striped them as RAID 5, and so on and so forth. Now, let's talk a little bit about SAN management. I know a lot of you are looking at these screens, and probably not a lot of you have ever worked on a SAN before, or this might be a little overwhelming. In most cases, in most environments, the SAN is managed by a SAN administrator, by a dedicated SAN administrator, at which point you are not required to manage the SAN. However, why not? If you are given the opportunity to learn a new technology, I strongly recommend that one of the new technologies that you acquire is storage technologies. Everything is moving in the area of storage. Now, while virtualization is awesome, you can quickly see how virtualization and storage go hand in hand. So if you're given the opportunity, if you're not in a large environment where you don't have a SAN administrator that's not going to let you anywhere near the equipment, learn SAN technologies. And if you are in an enterprise environment and you have the opportunity to maybe work alongside the SAN administrator to understand this a little better, it'll help reinforce your knowledge, and it'll only make you know things that you didn't know before, and this in turn translates into making you much more valuable in the outside world, or if you're going job hunting, or if you're trying to get a better job. I definitely recommend you learn SAN technologies and storage if you're given the opportunity.
Now let's talk a little bit about access control in a fiber channel SAN. Now every SAN component, such as the HBA or the storage processor, has something called a WWN or worldwide name. Now a worldwide name, you can think of a worldwide name as a MAC address. Now the worldwide names are useful for SAN administrators in order to identify the equipment for zoning purposes. Now a worldwide name is a 64-bit address. The format is as such over here. This is an example of what a worldwide name looks like. Now let's talk a little bit about access control. What if you had a lot of LUNs and you needed a way to prevent certain ESX servers from accessing certain LUNs, or even preventing some ESX servers from viewing or even acknowledging that there is a LUN that's available that they can attach to? How do you control that? What are the methods that are available to you? Now there's a few ways of doing this. There's actually 3 ways of doing this. You can either let the SAN administrators, if it's another group in your organization that handle that, you can let the SAN administrators control access to the LUNs, or you can ask the SAN administrators, hey, give me a chunk of LUNs, let's say 5 or 6 or 10 or 20 LUNs with these sizes, and I will control access and visibility of these LUNs to my ESX servers the way I want. ESX gives you the ability through the ESX software to control access or to control the visibility of SAN LUNs. Alright, so let's examine soft zoning. Soft zoning is the first method of access control or LUN visibility that we're going to talk about. What soft zoning does is the storage processor controls the visibility of LUNs based on worldwide name. So the storage processor here, for example, says that the following worldwide name, which belongs to HBA 1, since we're going to make this 1 and this 0, HBA 1 with worldwide name as follows cannot see LUNs 4 and 5. This is called soft zoning, when the storage processor controls the visibility of LUNs to the HBAs or to the ESX servers. Hard zoning occurs at the fiber switch level or the fabric level and is known as zoning or hard zoning. Hard zoning is the control of the visibility of storage processors based on a per port basis. So a fiber switch here has 1, 2, 3, 4, 20 ports. The fiber channel switch here says, for example, that port 10 cannot see storage processor 0. And in this case, we're going to make this storage processor 0 and this storage processor 1. So port 10 cannot see storage processor 0, and in turn, storage processor 0 is the storage processor that has access to LUNs 1 and 2. So the access control in hard zoning happens at the fiber switch or the fiber channel switch level. Now the third option is LUN masking. LUN masking can happen either at the storage processor level or at the hosts themselves level, which means that it controls the visibility of LUNs based on hosts. So you can configure, for example, ESX01 not to be able to see LUNs 3 and 4. You can control this either from the host itself or at the storage processor level. And that's why I named this host access. But the true name or the correct name for this is LUN masking. So you prevent the access or the visibility of certain LUNs based on hosts. Now when addressing fiber channel SAN LUNs, The name formatting is a four-part name as follows. It starts off with the HBA, the device that's being used. So for example, every HBA device is going to have a number. It's going to be preceded by VM HBA and then the number, whether it's 0, 1, 2, 3, 4, whatever it is. Then the storage processor number is going to follow. So that's the route it's going to take in order to access the LUN or the partition. Next comes the destination LUN number, and after that is followed by the partition number. So in the examples that we have down here, we have VM HBA 0 trying to get to LUN 8, partition 1 on LUN 8 actually. So the route that it's going to take is VM HBA 0, that's the device number that's given to the VM HBA, to the HBA cart on the ESX host. It's going to go from there, the storage processor 0, then it's going to access LUN 8, and from LUN 8 it's going to gain access to the first partition or partition 1. In the second example, we have VM HBA 0. Again, we're using the same device on the ESX host. It's going to access, again, storage processor 0. It's going to get to LUN 9 and in turn to partition 1. However, if you look closely to the second set of examples that we have, we're using VM HBA 1 via storage processor 1 to get to LUN 8 and in turn to partition 1. And we're doing the same thing for LUN 9 to partition 1. Now this provides some kind of redundancy to access the LUNs and the partitions that are on them via two different storage processors, two different routes, thereby creating what's known as multiple paths to a certain LUN. Now let's go to the whiteboard and take a look at a few more examples of how we can do this. So let's take a closer look at LUN addresses and at partition addresses. So an address is in essence a route. How does V8 or HBA 0 get to volume 2, for example, or partition 2, or even LUN 1 or LUN 2 or LUN 3? So here's the format. In the first example, we have HBA 0, which here represents VM HBA 0, connecting through the fiber switch or the fiber channel switch, the fabric, to storage processor 0, which means VM HBA 0, storage processor 0, LUN 1. Very, very simple. No confusion here. So VM HBA 0 connects through the fiber channel switch to storage processor 0, and in turn connects to LUN 1. In the second example here, we have HBA 1 connecting again through the fabric to storage processor 1 and in turn connecting to LUN 3. So now, if HBA 0 wanted to connect to LUN 2, what would be the proper syntax? I'm going to pause the video here, think about it, write it down, and when I start the video again, I'm going to give you the answer. So what we're trying to do in this exercise is we're trying to connect HBA 0 through the fabric to storage processor 0 and in turn connecting it to LUN 2. So what would be the proper address? It would be VM HBA 0 connecting through storage processor 0 and then connecting through LUN 2. If that's your answer, you get a cookie. It was correct. Now let's take a look if you wanted to have an address that went one step further to one of these partitions inside the LUN. So let's take a look at the first example here. Here we have VM HBA 0 again, connecting through storage processor 0, connecting to LUN 1, and in turn connecting to partition 1. The second example connects VM HBA 1 through the fabric to storage processor 1 to LUN 3, and in turn connects to the only partition available, which is partition 1. So now, what would the address be if I wanted to connect HBA 1 through storage processor 0, connecting to LUN 2, and in turn connecting to partition 2? Again, I'm going to pause the video, go ahead and write it down, and when we get back, we're going to give you the right answer. All right, let's see if our answers match. We're connecting VM HBA 1 through storage processor 1, all right, or through storage processor 0. My fault here. Yep, you can laugh at me. It's okay. It's through storage processor 0, through LUN 2, and again through partition 2. So again, if you wrote this down, I was wrong, you were right, and again, you get a second cookie now. So why do you need all of this? Why do you need the addressing and the masking and all that stuff? Because later on, when we're trying to configure our LUNs and our storage inside the ESX system, you will need these addresses in order to mask certain partitions or certain LUNs. You're going to need to tell ESX server what to be able to access and what not to be able to access. And the only way to do that is if you know how to get the addressing properly and correctly. Don't tell me this is not fun stuff. This is cool and this is exciting. So let's push forward now. Alright, now so far we've been talking about Fiber Channel SAN. Now Fiber Channel SAN implementation in an enterprise can be costly from several angles. First of all, in order to implement a Fiber Channel SAN, you need to implement a new architecture. You're going to need fiber channel switches, you're going to need HBA cards for your servers, and you're going to need a fiber channel storage devices. So it's expensive because the devices are expensive, the components are expensive. You're going to need to run fiber cables. You're also going to need to learn or acquire new knowledge on how to administer, how to properly configure a fiber channel SAN. All of those can pose challenges in an enterprise. So are there any other solutions other than a fiber channel SAN? Yes, there are. And one of those solutions is iSCSI. iSCSI stands for Internet Small Computer System Interface, is an alternative that's quickly gaining popularity in the enterprise. And for good reason. Number one, it's much cheaper than fiber channel on all levels. Components or non-components, it's cheaper in terms of disk as well. Number two is with iSCSI, you can use or leverage existing network infrastructure. Now because iSCSI goes over standard IP or TCP/IP, you're using existing Ethernet cards, you're using existing Ethernet switches, you're using your infrastructure, your existing network infrastructure to leverage this powerful storage device that you can implement. Routing, authentication, and encryption is also handled by TCP/IP. Education, you don't need to be educated on all these components. You're already familiar with IP routing, authentication, and encryption. So you don't need to introduce something or a new component to your environment. You already know this stuff. You're just reinforcing it and adding another component or another piece to the puzzle here. iSCSI is also internet ready, which means you can connect two geographically separated data centers using iSCSI. You have the capability of connecting a data center that's in Chicago with a data center that's in Las Vegas, for example, leveraging the internet. ESX server allows you to use iSCSI to boot from SAN. This is exactly the same as with the fiber channel, as long as you have an iSCSI hardware initiator or an iSCSI HBA, as we're going to cover in a bit here, you can boot off of a SAN LUN. Now, one thing I want to stress here. You can only boot to SAN when using iSCSI if you're using a hardware initiator or a hardware HBA. You cannot boot to SAN if you're using a software initiator. Alright, so let's take a look at some of the iSCSI SAN components. You're going to quickly notice here that there's several similarities between the iSCSI SAN components and the fiber channel SAN components. So let's take a quick or closer look here. Inside of an ESX server, you can have either an iSCSI HBA controller, also known as an iSCSI hardware initiator, or you can have an iSCSI software initiator. Now this is self-explanatory, but I'm going to go into a little bit of details. An iSCSI hardware initiator is similar to an HBA. It's an iSCSI physical device that you install in a server. An iSCSI software initiator is software generated or installed in order to replicate or initiate an HBA or an iSCSI hardware initiator. What's an HBA hardware initiator or an iSCSI hardware initiator? It's a NIC card. Now with software, it allows you to use the existing NIC card, but with software, you can turn this NIC card on or make it multifunction in order to become an iSCSI initiator. Now, second, you have the IP network instead of the fiber channel fabric or the fiber channel switches. Here we're using the IP network, the Ethernet switches that we currently have, the existing infrastructure that acts as the fiber if you compare it to the fiber channel SAN. On the other hand, you still have, or on the other side, you still have the storage processors for the disk arrays. Now again here, I didn't go into much details when we were talking about fiber channel SANs, about storage processors, but you can have those in either active mode or active-passive mode. But I'm not going to go into a lot of details about that. You can feel free to research this over the internet and see how you can configure those in numerous ways to either be active-active or active-passive. And again, you have the LUNs and the actual physical disks. Now you're going to notice here that I specified targets. Now with an iSCSI SAN, we call the disk array a target. Now why do we do that? There's a reason for that. And that is because a disk array in the sense of a fiber channel SAN is a grouping of disks that are in disk trays, for example. In the case of an iSCSI, you can turn any storage device that's attached to any server into a LUN or into a usable iSCSI storage device, provided that you have the right software installed. So let's say you have a server here that has local storage, for example, worth 200 gig. If you install the right software on the server, then you can connect it via iSCSI and have other devices use the local storage attached to the server. For this reason, we call the storage targets and not disk arrays, because in many cases they're not disk arrays and they can be local storage or any other kind of storage that is attached to a server.
Alright, so let's recap iSCSI real quick. So iSCSI, again, Internet SCSI, is sending SCSI disk commands and data over a standard TCP/IP network, right? So why use it, right? So it's low cost, use of existing hardware, as we've been talking about. You got Ethernet and NICs, you got your switches, you got your OS features, so on and so forth. Supports almost all vSphere features, everything you can do with fiber channel, you can almost do for the most part with iSCSI. The downside, performance and reliability. Again, you're at the mercy of the network. You're at the mercy of your network administrator. To build a proper iSCSI or even NFS/NAS environment in its truest format, you need complete isolation. And what I mean by complete isolation, I want a dedicated switch. I don't want anybody sharing anything on that switch. I want a dedicated subnet, dedicated VLAN. I want complete isolation. That, again, if you're doing it right, it might cost a little bit of money. I mean, you're rubbing up against what a fiber channel could cost at that point, and that's where you need to weigh in the pros and cons. But keep in mind, performance and reliability come into effect immediately with iSCSI, NAS, NFS. iSCSI Hardware Initiator is a special iSCSI NIC card. Again, it's just a regular NIC card for that matter, but it's dedicated for iSCSI traffic. It's hardware initiator rather than software initiator, and it's dedicated to move that particular SCSI disk communication dedicated from a physical hardware perspective, so it has some cache on it and stuff like that that would enhance it and make the performance a little better. iSCSI Software Initiator, now you're turning your existing NIC card into sort of like a multifunctional NIC card, where you're using it for your regular IP traffic, but you're also using it to transfer some of your data traffic. Not my favorite thing in the world, but it's also an available option for you. Your iSCSI target is known as the server that's running iSCSI. That's where typically the storage is at, so that's what we mean by an iSCSI target here. Alright, iSCSI uses IQN. So think of the IQN, which stands for iSCSI Qualified Name. It's the equivalent of the fiber channel worldwide name. It's the equivalent of the MAC address in an Ethernet, traditional Ethernet world. So it's what identifies iSCSI targets and initiators, and that's what helps connects them, right? So fiber channel, you have the worldwide names that helps connect, your servers and your hosts and your fabric, so on and so forth. You have your MAC addresses in the Ethernet world and the switches and IP tables and all that good stuff. In iSCSI, you have the IQN. The IQN is laid out in the following format. You have the date in year month format. You have the reverse domain. You have a unique organizational assigned name, for example, the host name. So for example, to break down what an IQN is made up of, you can start with the following. So in this case, we have 2007, which is the year. You can break it down by the month, for example, so it's 01, and you have the domain in reverse .com.wiredbraincoffee, and then you have like an organizational unique ID. In this case, it's iSCSI1. So this gives you a little bit more of an idea as to what is the IQN name and how it's going to be used. So again, we've talked about this, but I just wanted to capitalize on it one more time and sort of summarize these things. The justification for a SAN, especially with vSphere, first of all, near zero downtime. I'm not going to say it's zero downtime, because as soon as I say that, someone's going to have an outage and call me. So it's near zero downtime. Load balancing with vMotion and storage vMotion is available as possible. Storage consolidation and centralized management. Disaster recovery plays a big role when you're using SANs. Simple array migrations and storage upgrades are available. Use of advanced features like high availability, fault tolerance, distributed resource schedule, distributed power management, and so on and so forth, and more. So these are some of the justifications as to why you need to use a SAN. Now, with that being said, how about enough mumbo jumbo, enough death by PowerPoint? I hope you've been enjoying it, but let's go ahead and jump in and start doing some stuff. Let's configure the iSCSI, configure Fiber Channel, configure NFS. Alright, so we're back in our Virtual Center server here. I've selected my my host where I want to make all these configuration changes. We're going to click on the Configuration tab. We're going to be living in the Configuration tab. And from the Configuration tab, I don't have any hardware iSCSI initiators. As you can see here, if you go to Network Adapters, I don't have any hardware iSCSI initiators. So what I have to do is I have to enable the software iSCSI initiator so that I can use these adapters to also transport my SCSI commands over the traditional TCP/IP network. Now, to do that, the software SCSI initiator is disabled by default. To enable it, what we're going to do is click on Security Profile down here, and then we're going to click on the Properties of the firewall, and we're going to scroll down to locate Software iSCSI Client. Now, when you find that, just click the checkbox. We're going to click on OK. It should show up in the list here. There it is, Software iSCSI Client. Once that's available, what I want to do is I want to go to Storage Adapters, and I need it to show up. Now, in earlier versions of ESX, prior to 5, you used to have the iSCSI initiator show up here by default immediately. With vSphere 5, one of the changes is that you have to click on Add, and then you have to add the software iSCSI adapter. So as soon as you see that, you click on Add. Yes, I do want to add it, whatever. So we're going to go ahead and click on OK here. It's going to go through and it's going to do its thing, and then bada bing bada boom, you have the iSCSI software adapter that shows up. Once that shows up, we're going to select it, and then we're going to click on Properties, and let's take a look at some of the things that are available here for me, right? So the status of the software iSCSI initiator is enabled, so that's started. So let's go ahead and click on Configure. That's what I want to show you here. I want to show you the iSCSI name, the IQN name. So in our case, this is what the IQN name is. I mean, you can feel free to change it. Just make sure that you correlate that with whatever you're doing on the targets, etc., etc. For our purposes, we're going to keep it the same, but that's where you can configure IQN. Before we move forward, under the Advanced tab, this is where you can configure advanced functionality on how to manage some of the iSCSI traffic. For the most part, these are defaults that stand. Now, depending on your software, on your iSCSI SAN manufacturer or vendor, they might ask you to tweak some of these settings for enhanced performance. So go ahead and do that based on their recommendations, of course. But for the most part, the defaults should work just fine. Under CHAP, this is where you can configure authentication for iSCSI. So at the top here, you have CHAP for target authenticates to host. And you have a couple different ways by which CHAP can authenticate. You have do not use CHAP, do not use CHAP unless requested by the target, so on and so forth. You have just a couple different algorithms by which you are allowing the target to authenticate to the host. Now, for added security, the second sort of screen down here, it allows mutual CHAP. So the host also has to authenticate back to the target. Now, this is for extreme high security, and one of the only options that you have available here is once you've selected an option up here. So let's say we want to use CHAP, and then you have the option of using CHAP so that not only is the target authenticating against the host, but the host has to also authenticate against the target and back, and so on and so forth. So that way you have a mutual CHAP going back and forth. So for the purpose of our demonstration, we're just going to exit out of here. Now, you have two ways of allowing iSCSI to discover the LUNs that are available on the target. You have dynamic discovery and you have static discovery. Now, for the most part, the name is self-explanatory, right? But let me just break it down. With a static discovery, you are putting in the IP address of your iSCSI server, and you're giving it all the necessary information for that target. It's a direct connection that you're establishing. It's a static connection. For the most part, I like dynamic discovery for the most part because I am lazy. So if I click on add here, all I have to do is just tell it the IP address of my iSCSI target or my iSCSI server. So let's go ahead and do 10.4.14.83. That's technically all I would have to do, as long as it's the default port. You don't need any kind of CHAP if you don't want to. If I click on OK here, you'll see that it automatically discovered it. Now if I go back into the static discovery, it also lists the different static routes that it discovered to these targets that I have. So dynamic discovery just makes life a lot easier for that matter. Now, from a network configuration perspective, I need to bind one or more physical NICs so that they can be used to communicate with the target device. So it makes it easy here because now I can click on add and you can specify which NIC you want to bind so that the communication, the traffic, is going through that particular NIC to your iSCSI target. Now, this is the only NIC in my environment that meets the requirements. Obviously, you need a VM kernel port group in order to allow that traffic to pass, right? So the VM NIC 0 here meets the requirements. I'm going to use this to bind it to my iSCSI target. So I'm going to click on OK. It will automatically list it in here for me. And then if you wanted to add another one, possibly, you can click on add again. And as long as this meets the right requirements, so first of all, it needs an IP, a VM kernel if you're adding it on a separate virtual switch. Now, if you're adding it on the same virtual switch, you want to take note here of the NIC teaming and failover policy in order for you to configure this for iSCSI. So there are certain policies that you have to take into account here, as it says, so that you can allow multiple NICs to participate in a physical connection to iSCSI target. So again, keep that in mind when you're configuring this policy. Click on cancel here. And that's all there is to it from a iSCSI configuration perspective. Now that it's all configured, if I click on close, it's going to prompt you to rescan that particular HBA now that it's become an HBA because it's a storage adapter, even though it's a software iSCSI. I'm going to click on yes. And once it's completed down here, we're going to go up to storage. And we're going to click on add storage. Now keep in mind, again, two types of data transfers, right? We have the block, which is the disk/LUN, and you have the file level, which is your NFS. So if I was adding NFS, I'd go in here, and we're going to do that in a second. But because I'm doing block, let's go ahead and select, and this is the same for iSCSI or Fibre Channel. The process is the same. So I won't show you both, but I just wanted to show you what it's like for from an iSCSI perspective. I select disk LUN, click on next, and the LUN is immediately available to me. Now you might have in this list multiple LUNs based on what your SAN administrator has provisioned. You just pick the right one that you want, and you got some information on it. Again, you have what make and model it is, what the capacity is. If I click on next here, what file system do you want me to format this as? Do you want me to format it with the new file system of ESX5, which is VMFS ESXi5? I got to get used to it. VMFS5, or do you want it the backward compatible one, which is VMFS3 for whatever reason if you want to do VMFS3? I want to go with VMFS5 and keep everything the same. We're going to give it a name, so I'm going to call this iSCSI. Whoops, it'd be nice if I can type. Click on next. Do you want to take the entire space of the LUN, or do you want to just take a percent of that particular space, or a subset? I want to use all of space. And finish. Bada bing, bada boom. I now have a iSCSI data store that is configured and ready for me to use. Now, what if you wanted to use an NFS data store? Now again, as long as you know all the information for NFS, it should be very easy, relatively easy to add. So what I want to do now is I want to click on add storage. I don't have to do anything else in particular for NFS to work. I'm going to click on network file system, click on next. As long as you know the address to your NFS server for that matter. In my case, it's again 83, and the folder is vSphere 5. And you can give your data store here whatever name you choose to give it. I'm going to name mine just NFS. Now, up here, if you wanted to mount the NFS in read-only format, which means you can't write anything to it, but you're mounting it, you can read the files, you can grab the files, copy them, do whatever you want. You can lock it down if you choose to do so. Once you're ready, we're going to click on Next and see what happens. Voila, it automatically detected it. It detected the folder. Everything's good. We're going to click on Finish. And voila, you now have access to both iSCSI and NFS on this particular server. All right, so what I want to do now is I want to show you the properties of a Fibre Channel data store. Now, adding a Fibre Channel data store is very easy. It's the same process as iSCSI. There's no point in doing it again. Now, in order to do that, I have to log on to an actual production environment so that I can show you the different properties and the multipathing that you have in a Fibre Channel. But we're going to skip all the addition of the data stores, and we're going to jump directly into the storage adapters. And as you can see here, in this particular server, I have 2 Fibre Channel adapters, but I don't have any Fibre Channel LUNs that are attached to it. So in the other virtual center that I'm about to log into, we're going to come back into the same screen, but we're going to go to the properties of the Fibre Channel adapter, the HBA, and take a look at the multipathing and everything else that I have access to from that perspective. Alright, so we're on a different virtual center server now, and we're still in storage adapters. Now, one of the things I wanted to show you that if you select on an HBA card, when you have Fibre Channel LUNs attached to it, first of all, you're going to see these devices, these LUNs that show up here. And then if you click on paths, it's going to show you the path to every one of those LUNs. So remember how we were talking about the addressing when we were in the presentation during the lecture. This is again where you could see the path to these particular LUNs, and you can see over here on the right if there's active I/O being passed through, if you have the status is green, then everything's okay, so on and so forth. You can see the LUN numbering here, etc., etc. Now, this is from a what's connected to this particular HBA perspective, right? You can always do rescan of the HBAs or refresh. However, if you wanted to take a look at, well, how is the HBA routing through? What is the path selection like to these devices? You can come in here under Storage, and then let's say you want to select this particular one up here. It'll give you information about it down here. If we click on Properties, you have several different options. Well, first of all, you can rename the data store if you want to do so. If there was more disk space, you can increase the disk space here. If you wanted to initiate storage I/O, you can select this checkbox, which enables it, and then you can allow storage I/O to do quality of service and make sure you have enough bandwidth for what you're trying to do. Again, unless you're very advanced, I wouldn't recommend you play around with these things for now, at least until you get more familiar with it. However, if you wanted to manage the paths to the storage, down here you'll see a button called Manage Path. If you click on it, it's going to show you by default what is happening. So right now you have 2 paths to this particular data store, to this storage. So if one fails, the other one is always working. And you have it in a round-robin method. What round-robin means is it's going to utilize both paths. It's going to try to load balance traffic across both of the paths in an active format. So the traffic that's coming in is going to go through, for example, storage processor 0 and storage processor 1 at the same time. You have active path to the storage from multiple paths for that matter. If you wanted to change it from the drop-down menu here, you have options. Anything that says VMware in parentheses means that it's a VMware proprietary sort of like path that's installed. And the reason that VMware is in parentheses is because you can have third-party plug their own algorithms into the storage so that they are routing the traffic based on, for example, the storage manufacturer can provide you with an algorithm that maybe can load balance the traffic or can take care of the traffic a little better than what you have by default. I like the default stuff. I don't like to complicate things. Most recently used will always use the most recently used path to access the storage, and in the event that that most recently used path isn't available, it'll revert to another one. If you wanted to pin the traffic to always go to a certain path, you can select the adapter and then do force it that you're always using the fixed path to get to the storage. So you have multiple options here on how to configure access to your storage from this particular device. Now with that, that's all there is to it from a storage perspective. I want to switch back over to the presentation. There's a few more things I wanted to show you, and then we can wrap up this lesson. Alright, so we're coming down to the wire on this lesson, just a few more slides and we'll wrap up. So I just wanted to give you some storage terms that you must know. So you must know what a data store is. A data store is a VMware file system / logical volume. This is where virtual machines can live. This is where you can put the files of the virtual machines. It can be NFS or it can be VMFS, depending on the type of storage that you're using and the protocol and all that good stuff. Now, disk partition, it's an area on a disk set aside for a data store. So you can have multiple partitions on the same LUN. Maybe one of them has VMFS, the other one has, I don't know, NTFS. However, I don't recommend that. If you're creating a LUN, I would recommend that you have the entire LUN dedicated to VMFS. An extent is a disk area that can be added to a data store, so in case you want to increase the size of the data store. Now that's not, valid typically anymore these days, since VMFS 5 now allows you to do 64 terabyte data stores. With all due respect, if you want to extend that, then you have some other issues. Fiber channel, otherwise known as FC, it's high-speed storage technology with fiber channel HBAs, fiber channel switches, otherwise known as the fabric, fiber channel storage processors, and disk. Internet SCSI, again, it's SCSI over TCP/IP. Server is the initiator and storage is the target. LUN, logical unit number, is again, it's a collection of physical disks that are logically grouped together and presented to a host. Multipathing failover allows you to use more than one path to the storage, offers failover and redundancy. NAS, network attached storage, is networked disk storage that ESXi uses. It uses either NFS or NAS for that matter. NFS is network file system. It's a file sharing protocol used with ESXi and Unix/Linux servers. Raw device mapping, otherwise known as RDM, it's a special type of storage disk that is presented through the vSphere kernel directly into the virtual machine. Spanned volume, it's a dynamic volume spread across a number of extents. Volume, it's a disk volume, it's a logical storage unit. Again, pretty self-explanatory here. Alright, so what's in a data store? Virtual disks are typically in a data store. It's a virtual memory resides there. The VM configuration file is there. The log files are there. Core dumps are there. Anything you add, like, for example, an ISO file, can also go into a data store. ESXi server storage options. What are the different options that you can have with ESXi? You can have obviously local disk with VMFS. You can have SAN in the form of iSCSI software. You can have the iSCSI hardware. You can have the fiber channel. You can have NAS in the form of NFS. And with vSphere 5, you now have the vSphere storage appliance as well. As with everything else, before you buy any type of storage for vSphere, I strongly recommend you consult with the compatibility guide, and I've given you the address. VMFS specifications and maximums. It's optimized for storing virtual machines and high performance. It's cluster file system, which means multiple ESXi hosts can access this file system. Not a lot of features when compared with NTFS or other file systems. It's strictly designed, configured. It's custom built to run virtual machines the best way possible. VMFS 5 is the latest VMFS version that we're on today. You should have only one VMFS volume per LUN. Again, I mentioned that earlier, but out of best practice, that's what you should do. The maximum size of a VMFS volume today is 64 terabyte. That's a significant upgrade from the 2 terabyte limit that we have. And then best practice dictates the format LUNs with 8 megabyte block sizes. Alright, so we're at the end of this long but enjoyable lesson, right? Whoo! Alright, so we started off by talking about Storage 101. We talked about virtual disks and virtual VMware file systems and what you can do with both and why you need them, and the fact that the storage, the actual storage, is completely abstracted from the VM. The VM, all it understands is the vDisks, and VMFS is the file system that sits between the vDisks and the virtual machine. Data transfer, we talked about the fact that you have block level and you have file level. Block level is for iSCSI and fiber channel. File level is for NFS. We compared the different types of storage technologies from NFS to iSCSI to fiber channel, the differences in feature sets, in price, etc., etc. We talked about the fact that a storage area network is comprised of primarily, when you say storage area network, you mean a SAN, but in some cases you also could mean an iSCSI SAN. Anything that's block level is considered a storage area network, and we went through the different components of iSCSI and SAN and NAS for that matter as well. We talked about Fiber Channel SAN components as well. We talked about how you address Fiber Channel SAN, how you use the worldwide names, and so on and so forth. We talked about iSCSI storage. We talked about how you address iSCSI storage with the IQN and what that stands for. We then moved on to, well, why do you need a SAN? What are the justifications of needing a SAN? Things like enterprise class features like vMotion and HA and DRS and fault tolerance. We talked about the storage terms that you should be intimately familiar with, like the data stores and so on, that the extents, etc., etc. We then moved on to talking about what is a data store. Why do you need a data store? What goes into a data store? What are the different files that go into a data store? We talked about ESXi server storage options and the fact that you can do local, you can do SAN, SCSI, iSCSI, Fiber Channel, NAS. You can also do the vSphere storage appliance with vSphere 5 now. Finally, we talked about VMFS specifications and maximums and the fact that it's best practice to have a single VMFS on the LUN. 64 terabyte is the maximum VMFS volume size, etc., etc. I hope this lesson was very informative for you, and I'd like to thank you for viewing.